is the following. Suppose I give you a vector. Okay, so let's look at two dimension again. Suppose I give you a vector V and I multiply on the left by the matrix A. So that means I'm considering AV, right? So what is the effect of AV? Huh? What will be the effect of AV? What will AV do? So V is in, let's say 2 cross 1. AV will also be a 2 cross 1. Let's say it's a 2 cross 2 matrix. What is the effect of multiplying a vector by a matrix? What will happen? You will get another vector, right? AV is another vector in R2. So that means, let's say it is somewhere here. This is AV. So by looking at this picture, it's very easy, right? So you multiply by A, matrix A, then all that it does is it will rotate, right, by some angle, and it will shrink or expand, right, depending on what the vector is, right? For example, if I operate, let's say, let me call this as A1, but if you operate, let's say A2, A2 will do this on the vector, right? It rotated by a large amount. Not only that, it increased the length also. Right? That's how I can think of. Right now, what is it that you will observe about A1, A2? So just looking at what happens to V, right? So it rotated the vector by less than 90 degree, right? A1 rotated the vector by less than 90 degree. So that means this is your orthogonal to V. And now if you take inner product of AV with V, what do you get? A positive number, right? Do you agree? So whenever A rotated the vector by less than 90 degree and take the inner product, you'll always get a positive number. What happened to A2V? A2V, the situation is quite different, right? Maybe I'll not write it like this, okay? So A2V, this is A2V, okay? Now, what is the impact of it? So if I take the inner product, what do I get? This is the inner product, right? It's negative. Do you agree? So now, suppose this matrix is such that you take any vector V, operate A, it will not rotate more than 90 degree, right? Suppose I choose such a matrix, right? What is the situation? So you take any V, for any V, right, in Rn, in general Rn or R2. If you look at AV and inner product with V, so what is the inner product? V transpose, right? V transpose AV. So what is this? This is V transpose AV or AV whole transpose V. Both are same, right? V transpose AV, right? Is that clear? Okay. So now this is positive, right? What does that mean? So you take any vector, operate A and take the dot product, it will always remain positive, right? So we will give a name for such matrices. We will call that as what? Any idea? Those who have studied matrix theory or maybe some data analysis, some online course, you would have studied such matrix, right? Any idea? Huh? Okay, it's called positive semi-definite because it's greater than or equal to 0. If it is greater than 0, it's called positive definite. Okay, so let's define that, right? So this is definition. Matrix A belonging to Rn cross n is said to be positive. Okay, I'll write semi-definite. If for every x that you take in Rn, x transpose Ax is greater than or equal to 0. Okay. If it is strictly greater than, we call it as definite. Okay. So maybe I'll write it in color. So if it is If it is this, then you get this. Okay. What is negative semi-definite? It's easy. It should be less than or equal to 0. What is negative definite? Less than 0. Or the other way of saying matrix is said to be negative semi-definite if minus A is positive semi-definite. Okay. Same thing. Is this fine, everyone? Okay, positive semi-definite. Okay, now what can you say about such matrices, right? What about the entries of such matrices? Suppose I say that A is positive semi-definite. What can you say about the entries? Huh? Can you talk about the entries of such matrix? I mean, what can you say about the entries? Huh? Any idea? Can you say something about entries or whatever, right? Let's see. Let's look at an example. Okay, so suppose I have A11, A12, A21, A22. So simple 2 cross 2 matrix. Let's say this is positive semi-definite. Now let's see what happens if I multiply by 1 0. See, 1 0 is any x, right? So, and I transpose. What do I get? When I multiply this, I'll get A11, right? So this, when I multiply, what do I get? A11, A21, right? When I multiply by 1 0, what do I get? A11. But what is our definition? It says it should be greater than or equal to 0, right? Do you agree? So that means A11 should be 0, greater than or equal to 0. That is one thing. What can you say about A22? Well, instead, if I use this, instead of this, I use this, right? What do I get? It selects A12 and A22, and then when you multiply this, it selects A22. So similarly, A22 is greater than or equal to 0. So if I take n cross n matrix, how do you generalize? I can take 1 0 0 0, 0 1 0 0, 0 0 1 1 1 0 0, and so on, right? So if I multiply, what do I get? All the diagonal elements should be positive, right? Non-negative, right? So that is one of the characteristics of a positive semi-definite matrix. So suppose I give you a matrix. Now you know how to identify. At least you can rule out. So suppose I give you a matrix with one of the diagonals being negative and some of them being positive. Can you for sure say that it's you can for sure say that it's not positive semi-definite, right? Okay. Now, if it is positive definite, then it should be non-negative, meaning it should not even be 0, right? 0 is also it should be avoided, right? Is that fine, everyone? Okay. So this is one quick check whether a matrix is positive semi-definite or not. Diagonal should always be non-negative. Okay. Let's look at another example. Okay, so this is an example in probabilities, right? So suppose